everybody. Thank you for having me here. My name is Adam. I'm from the United States. I'm here visiting Bhutan for a week, your lovely country, and I'm honored to come here and talk to you about what I do. So I work at NASA in the United States. Have any of you heard of NASA before? Yeah? Yeah? Who else? Everybody? Okay, so I want to start with a question for you guys. Who can tell me what is space? Anybody? Anybody? What do you think? There's no wrong answer. What do you think? What do you think? When you look up in the sky at night, what do you see?
Stars.
Stars, right. What else do you see up in the sky at night? Moon, right. In the daytime, what's the big? The sun. So all of that stuff is all in space, right? We're here on Earth. Everything out there is all in space. So our job at NASA is to send people, like you and like you, into space, okay? So today we're going to talk about how we send people into space, the kinds of things we do to send people in space to make sure it all works okay. But we're also going to show you, the first thing we're going to do is we're going to show you right now how to build a rocket, okay? Who knows what a rocket is?
Yes, I know.
What's a rocket?
And there you can fly to the moon.
Right, so you can fly to the moon. What do you think?
And we can see stars.
Right, you build a rocket so you can go into space and you can see stars and everything. Exactly right. First thing we're going to do is we're going to teach you how to build a rocket, okay? Is that okay? Can we build a rocket right here?
Yes.
All right, so we're going to do it in a different kind of way. I'm going to build 3 rockets today, okay? And I'm going to show you how to do it. The first rocket's going to be a really, really bad rocket. I want you to see why it's a bad rocket, okay? Because then we're going to make some improvements to it, and we're going to make it better. And I want you to see why it's better. And then lastly, we're going to make the really, really good rocket. But it's important you understand the bad rocket, why it's bad, then a good one, why it's better, and then the best one, why it's the best, okay? You have a question? What's your question?
But as it is not strong, then you cannot fly to the moon. Anders just go out of the things, and then you flew down to the earth.
Right, so if the rocket's not strong, we cannot go to the moon. So I'll tell you right now, so there's no disappointments, the rocket today will not go to the moon, okay?
Yes.
We're going to try to go far, but we might not go to the moon today. The first rocket we're going to build... Is this a rocket?
No.
What is this?
A balloon.
But it actually is a rocket. A rocket like
can
this.
fly
A rocket like this is nothing but what we call stored energy. I just created some energy by blowing into this balloon, and the balloon's holding it all right here. The way a rocket flies, it's just releasing stored energy. Okay? So this is my first rocket. Who's seen this kind of rocket fly before? Is this a good rocket?
No.
Would you want to ride on this rocket?
No.
Well, let's just check. Let's just try it because we never know. Maybe we want to ride in this rocket. All right. So before we do a launch, though, we do a countdown. Okay. So we start with 3. We go 3, 2, 1, and then we're gonna let it go. We're gonna launch. Okay.
A little bit.
Will this one go to the moon?
No.
Probably. Okay. Let's just try it though. Okay. Here we go. 3, 2, 1.
Go.
Where'd it go? That's our rocket. We went from there to there. Who wants to ride on that rocket? Nobody does. That's a terrible rocket.
I want to see if I can do it.
This is a terrible rocket. And you know why? Because there's no way to control it. I aimed it this way, and it went that way. It went this way, then that way, then this way, and it ended right there. Nobody wants to go in a rocket you can't aim. So we need to build a rocket that we can aim, okay? So we're going to go on to rocket number 2, okay? This is our better rocket. So all I'm going to do is take... This looks like some fancy contraption. It's nothing fancy at all. It's just a big bubble, okay, and a hose and a little pipe on the end of it. There's air in this, right? So I can squeeze it and air comes out of the end of this. You can feel air come out of the end, right? You can feel the air. So I'm going to use the air out of this like a balloon, and I'm going to build a rocket on the end of this, okay? And we're going to do it right here in front of you so you see how it works. So this is our second rocket that's going to be better than the first one because we can aim this one. So all I'm going to do is take my rocket like this. I'm going to take a piece of paper just like this, nothing fancy at all, and I'm going to wrap it around the tube, okay? I'm going to wrap it around the tube just like this. Hang on 1 second. It's important to get a good, nice, tight fit around the tube. Okay. We're in business now. Get a good, tight fit around the tube. Here we go. Now all I'm going to do is just tape this closed, okay? Get my tape over here, ready to go. 1 piece of tape, 2, and then 3. Okay, I'm building this in front of you because I want you to see how easy this really is to do. You guys can do this on your own very easily. So all I did was build this little cylinder around the tube, okay? Nothing special. Now right now, if I squeeze this bubble, nothing happens, right? The air comes out of the top. So we have to seal the top off somehow, right? We're not going to build some fancy cone on top. All I'm going to do is take the top, and I'm going to just fold it like this, fold it over, and then kind of fold it back on itself, just like this, okay? That's all I'm going to do, just like that. I got to tape this closed, though. Okay, we're going to tape it closed. Put 1 piece of tape. We'll put a 2nd piece of tape just to be safe. Now we're starting to look like a rocket, okay? All we did, this is really simple. Piece of paper wrapped up in a tube, and all I did was tape the top closed. So the purpose of this rocket is now we want to see if we can aim it, right? The first one, balloon went everywhere. This one, at least, I can aim in a certain direction, and I'm hoping it'll go straight, okay? So we're going to see if this one does any better than the balloon. All I'm going to do with my bubble here is just step on it like this. So all the air in the bubble all goes through the hose and goes out to the rocket, okay?
Yes.
Make sense?
Yes.
So we're going to see if this one does any better, and then after this one, we're going to make a really good one, okay? But it's important you understand how we progress from the first one to the last one. Okay, so here's the next one. So I need a launch countdown again, okay? So I go 3, 2, 1, launch, okay? So here we go. 3, 2, 1, launch. Whoa, that was pretty good, right? Would somebody go pick it up for me? Okay, let's bring it back. Let's bring it back. Now who saw that one once we actually launched it? As soon as it went straight for a little while, and then what happened? Did anybody notice it kind of turned? It just turned all of a sudden because there was nothing, once it started turning, there was nothing there to correct it, to make it keep going straight. It just started turning and tumbling. If you didn't believe me, if you didn't see it, watch it again. We're going to launch it again one more time and watch. It'll go straight for a little bit, and then all of a sudden, out of the blue, it'll just turn left or turn right and start tumbling. Nobody wants to be on a rocket that starts tumbling like that. So let's watch it again. It'll go up, and then it'll kind of just turn one way or the other. Okay, ready? 3, 2, 1. Whoa. There it is. It went right over there. Okay, so that was our second rocket. Definitely better than the balloon, right? Better than the balloon?
Yes.
But will that rocket take us to the moon, though?
No.
No, because it went straight and then it crashed all of a sudden. We don't like rockets that crash. We want them to keep going straight, okay? So what am I going to do? I'm going to add something called fins to the rocket, okay? And my fins are going to be nothing more than 2 little pieces of paper like this, okay? They're index cards. They actually used to look like this, and I just cut it in half into 2 pieces, okay? So we're going to take these index cards just like this, and we're going to fold them 3 ways, okay? So I'm going to take my card like this. I'm going to fold it once this way, and I'm going to fold it once another way, just like that, okay? So now all I have is a little index card that's shaped like this. See it? Nothing fancy at all. All I did was take a piece of paper, a stiff paper like index card, and folded it just like that, okay? Now what I'm going to do is I'm going to tape it onto our rocket, onto the back of the rocket, okay? So I put it on just like this. I'm going to get my pieces of tape. One on the front side, and one on the back side, right. Exactly right. So just like this. So now I have 1 fin on my rocket. 1 piece of paper, but it's really 2 fins. See it like that? Okay. Now, in rockets, we like to have things that are symmetric, meaning they're the same on both sides. So I want to build a second fin on the other side. Okay? So here's what we're going to do. Put the rocket back on like this, and I'm going to get my second piece of paper. I'm going to fold it the exact same way. Okay? I'm going to fold it like this, and I'm going to fold it like that. Now I've got the two pieces of paper. I have my fin. So here we go. Here's the second fin, just like that. Nothing fancy, just like that. Okay. Now I'm going to tape this one onto the rocket too. Tape it onto the other side. Okay. Put one piece of tape on the front. And the back, exactly right. So you guys can build these. You'll be able to build these in your sleep by the time we're done. These are really easy to build. You don't need a pump. I'll show you why later, okay? I'll show you how to do it without a pump. Because what you do have is this, right? This is a pump. Take the water out of it. It's an empty, all this is an empty bottle. It's air. Once the water's out of here, there's air in there. All you do is you can take a little hose like this and tape it onto the end of it, and we find some kind of a little pipe like this, and there's lots of ways to find a straight pipe like this, and tape it to the hose, then you have the exact same thing. The only reason I didn't do it that way is because I wanted to be able to bring this home with me, and this is a little more durable. It travels a lot easier. So, but you can make this yourself with a plastic water bottle, okay? Okay, so now we're going to build, we had our really bad rocket, we had our better rocket, and now this is the best rocket, okay? All we did was add on these little things called fins onto the back of it. And we're going to see if that made a difference, okay? So let's see, our balloon went there. Our first rocket went just past the white flowers. Our second rocket went just past the table over there. So our goal for this one is to go past the white flowers. We want to see if we can go past the white flowers, okay? Out of the world now, I don't want to disappoint you. This rocket might not go to the moon today, okay? But we want to go past the white flowers because you can build better rockets beyond that. But our goal right now is just to go past the white flowers, okay?
Who can sit on it?
I'm just going to look out past there's a road over there. Okay, so what we're going to do is we're going to aim over the tent, and we're going to go see if we can just go past where the white flowers are, okay? I won't aim it, don't worry, I won't fire it. Okay, so here we go. Our goal was past the white flowers. All we did was add fins. Okay, no, hang on, we gotta get ready first. In position. Okay, I think we're in position. 3, wait. 3, 2, 1. Whoa. Whoa. All we did was add the fins. So what happened there? We're going to do it again. We're going to try something different. Before we had it, the fins, when the rocket would fly in the air, imagine this is the rocket. As soon as it would start turning, there was no way for it to correct itself, right? Once you added the fins to the back of it, as soon as it starts turning a little bit, as it's flying through the air, once it starts turning, the fins are pointing right at the air, and they actually want to push it right back into being straight. If it turns this way, the fins push it back. If it turns this way, the fins always push it back. The fins are always helping to keep it straight in alignment where we want to go. Make sense? So all we did was add fins, and look at how much further it went. I hit it the exact same way, built the exact same rocket. All I did was add fins. Okay, so now, when we're at NASA, though, we don't like to have a mission just to go anywhere. We like to have a specific destination, okay? So we need to find a place for our rocket to land around here. So let's look around and see if we can find a place, a good mission for our rocket. What do you guys think? Do you think we can hit that tree over there? Is that too far? What else do we see around here? Any other good missions? Maybe the tree's a good mission. But I need help, though. This I can't do alone. I need some volunteers. Who can volunteer for me? Nobody? Okay, you want to be a volunteer? Okay, so you come up here. You are going to be my chief engineer. Okay, can you be my chief engineer? So the role of the chief engineer today, we just had a rocket launch. We need to inspect the rocket to be sure it's safe to fly again. Okay, can you inspect the rocket for me? You can hold it and look at it. And if you see anything that's wrong in it, you can bend it back, you can fix it, do whatever you like, okay? Your job is to inspect the rocket. Okay, I need another volunteer. Okay, you want to volunteer? Okay, come on up here. So your job, you are going to be responsible for trajectory design. Can you handle that? You know what that means? So what that means is you are the one, well, I'm trying to tell you, you are the one who is going to set the trajectory, meaning you're going to aim this, okay? So where's our target? Our target's the tree, right? So you have to set the trajectory to be sure we hit the tree, okay? So you're going to come down here like this. Actually, what I want to have you guys do, maybe you can, I don't want to go right over your head just in case it goes off track. Okay, so now, yeah, the chief engineer is going to load the rocket. Okay, perfect. Okay, now what you're going to do is you're going to hold it. So what you're going to do is you're going to get on the side of it, just like sit where I am right here, like this. But you're going to go over here on the side. So you're going to come over here, just like this on the side. Okay. So you're going to kneel down, and you're going to aim this way though. Okay, so you're going to be looking over at the tree. Okay, and you're going to aim in that direction. Now the last volunteer, I need one more volunteer. Okay. So your job, you ready for your job? You are my launch director. Okay? Can you do that? Okay. So we're going to unload the rocket first because we need to test something. Your job as launch director is to actually do the launch. You are going to be doing the launching. So that means, here's the bubble like this. You're going to stay crouched down like this. Okay? Aim at the tree. And your job is when we say 3, 2, 1, launch. Your job is to go like this. Okay, you jump on the bubble. So let's practice, okay? So I say 3, 2, 1, launch. Perfect. One more time. Let's get it right. 3, 2, 1, launch. Okay. Jump really hard though, okay? Like go like as high as you can. Like boom. Okay? One more practice too. Jump as high as you can. 3, 2, 1, launch. Perfect. Okay. Land with both feet on the bubble as best you can. Okay. Now, trajectory design. How are we looking?
Fine.
Pretty good? Okay. So we're going to look, let me check out your trajectory. We're going to come a little bit lower. Okay, just like that. Okay, that look good?
Yeah.
You think we're going to hit the target?
Yeah.
Okay, my chief engineer, can you load the rocket for me? Okay, let's do one last check. Chief engineer, let's do one last double check. And let's push this off. And make sure your finger is not on the paper, okay? Hold the blue. Okay, let's do one last check. Everything looks good?
Yes.
Okay, put it right there, just like that. Okay, now your job, trajectory design, make sure we're aimed right, okay? We're gonna come down a little bit. Okay, just like that. Okay, looks good?
Yeah.
Okay. Now, I need the help from everybody else to do our countdown, right? This time we're going to start from 5, though, okay? Not quite yet. I need to be sure all my team is ready, okay? So trajectory design looks good. Chief engineer, are you ready to go?
Yes.
Ready? You say go.
Go.
Launch director, are you ready? Say go. Go. Trajectory design, are you ready?
Go.
Go. Okay, so you ready for the countdown? 5, 4, 3, 2, 1, launch. We hit the tree! Perfect shot! Good shot! All right. How does it fly? So it flies because we had the rocket, right? And we essentially, imagine if you had a something in your hand like this. Let's take this sticker. Okay, I'm going to ball it up in a ball. And if I blow on it really hard like this, you see how it kind of moved a little bit? But this wasn't shaped like a rocket. This is shaped like a piece of paper. This is not very good. If this was shaped like a rocket and I blew on it right, it would fly just like that. So because we blew on it by stomping on the big pink bubble, that pushed air into the rocket. And the air just pushed it all the way over there. Same kind of thing. Same as just blowing on it, it's just that it's shaped differently. Make sense? Good question, good question. Who else has a question?
Why the things,
The fins?
help?
Why do they help?
Okay.
What happens is, so imagine the rocket's going in the air like this, going this way. If the rocket starts turning like this, the air is going to hit this big fin and push it right back into the right direction. If the rocket starts turning this way, imagine the air blowing this way, blows it right back into the right direction. Any way it turns, the air, which is blowing from this way, always blows it back into the right direction. If it turns this way, the air blows it back because it's going like this, right? Any way it turns, the air always pushes it back into the right direction. So how many of you've seen airplanes, right?
Yes.
Have you seen on the back of an airplane, there's a big thing called a vertical tail?
Yes.
That's a big fin, right? It's just like this on the back of an airplane. With an airplane, you know what its job is? Is if an airplane starts going left or starts going right, the vertical tail is the big fin that keeps it going straight. It always helps to correct it. If it starts steering this way, it brings it back to center. Starts steering this way, it brings it back to center. It always helps to correct it, just like fins are. So you guys can make these same kinds of rockets.
Als je even rocket, als je doet dit, oké, dan kan dat.
Yeah, so in the pilot, what they have on an airplane is they have fins just like this, but they have a little surface on the back that they can move. So when the pilot goes like this, what he or she is doing is moving part of the fin. The fin actually can move on an airplane. So they steer the airplane by moving the fin like this. That's how the airplane turns left or turns right.
And how do the birds do it?
How do the birds do it? That is a fantastic question. Have I given you a sticker yet?
No.
That's a really good one. I'm going to give you a sticker. Okay, so she asked a really good question. She said, how do the birds do it? Okay, so let's think about birds. Birds, they have wings, right?
Yes.
The back of a bird, have you seen the feathers near the tail?
Yes.
So if you ever watch a bird fly, they do lots of different things. Their tail, actually, they can, with muscles, just like you move your arms and legs, they have muscles, they can move their tail like this. They can move it left, they can move it right. They can also take their wings, and they can turn a wing like this or turn a wing like this. All they're doing is they're just taking their fins and they're moving them to help steer help steer themselves left or right. Same thing, just like a rocket. Okay? Make sense?
How do birds fly? Well, it mostly has to do with the shape of their wings and how they move them. When a bird flies, it flies through the air, and the air flows over and under the wing. If we look at a section of a bird's wing from the side, we see that it is big up front and then tapers off toward the back, kind of like an airplane wing. When talking about flying, this shape is called an airfoil. Now the air flows around the wing like water in a river. If you've ever been on a river, you'll notice that it moves very slow at the wide parts, but speeds up really fast when the river narrows. This is because the same amount of water that was in the wide parts now has to move through a much smaller space at the narrow parts. And so the air is just like several rivers flowing side by side past the bird's wing. The shape of the wing, the airfoil, makes it so the river of the air that flows over the top of the wing gets squeezed and narrowed. And just like a river, this air has to speed up. And the river of air that flows under the wing actually widens and slows down a little. Now imagine you are traveling down this river of air and you have a cannon on your boat. The airfoil is an island and you are trying to shoot it with your cannon. But you have to reload the cannon every time you fire, so you can only shoot it once every few minutes. If you are going really fast down the river, you will only have time to shoot a few cannonballs at the island. But if you go down the wider part of the river at a much slower pace, you will be able to hit the island with more cannonballs. This is kind of what happens with a bird's wing, but instead of cannonballs, it's the air that's landing on the wing. Because the air on top is pushing less on the wing than the air on the bottom, the wing gets moved upward. This upward push is called lift, and it's the main reason birds are able to fly. But there are other tricks birds use too. To get more air to pass over their wings, birds will flap them, especially when taking off. When they do, they rotate their wings forward and down and then lift them back up to start over again. Rotating the wing forward causes the lift from the air to push the bird not only in an upward direction, but forward as well. This forward push is called thrust. As you can imagine, all this flapping takes a lot of energy, and so birds have large lungs to help them breathe and strong muscles to move their wings. Not only that, but their body is shaped to cut through the air efficiently, and their bones are hollow, which makes them very lightweight to begin with. So a bird relies on many tools to get through the air, not just its wings. As for people, we are heavy and can't produce the energy needed to fly by ourselves, so we use aircraft to get through the air. And even though we use machines to get off the ground, it's still fun to imagine that we can fly like the birds.